Hi, can you hear me?
Yes,
Excellent. You must be Mike.
I am.
Good to meet you and good job on this.
Oh, thank you.
It
Oh, looks
turned
like
out
you got some progress on it.
I got it making signals. Yep.
Excellent.
Yeah. Only ran into one problem with it, and that was with the selector switch.
Uh-huh.
I I couldn't get the RF side to work, and so I was doing continuity checks through the switch and the pin number, what is it? Pin number 6 was supposed to be the common one, and that didn't work. I had to connect up to the pin labeled V, which is in the middle of that switch.
Yeah, the middle one is the common, and then all around the outside is the ones that the common goes to.
But the schematic says it's pin 6. I think
Oh,
there might,
does it?
I think so. There might be an error in the schematic.
Let's see. Oh, I think that's pin 6 on the board, not on the contactor. Because I didn't label the contactor one.
Yeah, the schematic it shows right here
Yeah.
as,
Um,
as pin 6 of that switch.
Let me pull this up. Yeah, I think that's a great point. I'll bring that up tonight. Thank you.
Sure.
Because that's actually referring to, let's see, I've got it called up here.
It goes to J3 pin 5, actually, is the other end.
Oh, yeah, yeah, no, you're right. You're right. That shouldn't be 6. You're right. I see. Yep.
But it worked great once I got that.
Okay, yeah, thank you. I will correct that if I can. I wonder if I can. I may not be able to. The problem is, okay, yeah, I see. That's interesting. Yeah, those numbers actually don't relate to the rotary switch itself. That's a symbol that I have in
Uh,
the schematic library.
yeah, yeah,
But no, that's a great point. Thank you.
yeah.
Yeah, because all the others are, if the other switches are numbered too, but those numbers really don't mean anything.
Right, right,
It's just whatever the symbol showed up in the schematic editor.
right. You see, you could pick any 5 points
Yeah,
around that switch. Yeah,
yeah, and in the center is the common. Oh,
yeah.
great point though. Thank you, and I
Well,
apologize for that.
there are 2 pins in the center, and only one of them is the common.
No, the other one is common also, but for the other set of
The
pins.
other half.
Yes.
Okay.
And
Well,
so
in my case, it was the V pin was the common one.
yeah, yes. Yeah, so that particular switch isn't represented.
Isn't in the library. Yeah.
Yeah, because that's a 12. It's a well, it's a double pole 6th row switch essentially, right?
Hmm.
And I'm only using half of it,
All right.
and I'm only using 5 of the 6 pins of it.
Yeah. Yeah.
But no, I'll bring that up tonight. That's great. Thank you.
You're welcome.
Limitation of the schematic editor. I wonder if I could have gone and edited the symbol.
Which editor are you using?
I'm using KiCad.
Yeah. I think you can edit existing libraries.
Yeah, I'd have to, yeah, because I'd pull it up, create my own symbol out of it, and then make the edit.
Yeah.
No,
Nice job in the box.
excellent point, though. Thank you.
Sure. Oh, I had one other question if now's the time.
Sure. While we're waiting for people, we can do that.
The drawing of you had the labels in a document for the front
Yes,
panel. Is that to scale?
it is.
So if I s- swelled it up, I could print a vinyl sheet for it then.
Yeah,
Okay,
yeah. Then you can change it to however you want it to look. But yeah, I got it to all of that should be to scale as long as your printer prints out, 1 to 1.
right.
Um, I ran into a problem with, and I think I put it in the document. I ran into a problem with we have a Brother multifunction printer, and when I sent it to it from Word, um, it kept scaling it by like 3%. And so
Mhm.
I had to resize it a little bit. And then
Yeah,
I found out, I went online and I looked at that, and they said sometimes if your drivers are outdated, so I redid my driver and then it scaled properly.
it did.
But yeah, that can be a little bit annoying. It,
Very, yeah,
do it on white paper first, see how it looks, and then
right. Right.
Yeah, do a test print and check
yes.
it out before you go all in.
Yeah,
But yeah, you can also, change the document. We should probably, if someone comes up with a really nice looking face, we should probably share that for everyone. I just threw something together real quick with some numbers to, um, you know, kind of make it look right, but I didn't spend a lot of time. I was too busy trying to get everything else going.
yeah. It's a lot of work.
Oh yeah.
Yeah, it was impressive.
Thank you. That's cool. You got it working. I
Yeah,
actually used mine today to troubleshoot a radio.
that's that's yeah, that's the proof is in the pudding, right?
Yep. Yeah, I have uh, actually I got a schematic for it. I'd requested a schematic. Um, I picked up this at an estate sale for $5. And what's cool about it's Panasonic, and then it came in this, which is
Oh, yeah.
it's for car. You plug it in,
Mhm.
got a power supply and stuff on the back,
Hmm.
and you
Oh,
can
yeah.
slide this in and lock it in.
Yeah, I've seen those kinds of things. I had one once that it still worked, of all things. Go figure. And I pulled it out of a house that I knew the lady that used to live in the house before it went the house went to hell in a handbasket. But I pilfered it out of this house and she didn't mind either way. But it was one of those insert portable things.
Well,
And
they're usually missing the thing that you plug it into.
oh,
Yeah.
yeah.
Well, and even better yet, this even has the key, which is really cool.
Wow.
Yeah, that's really
Ooh.
nice. Don't have to rekey it or anything.
Yeah,
That sounds like some of those business computers from years ago, or even some of the laptops that had the lockable dock.
right. But
Blaupunk
yeah,
made those too.
yeah, it was dead. But what I did was it's got an input jack for a phono, and so I just ran that AM generator into the input jack for the phono, and I could hear a very faint sound. So I know I probably got a bad cap. I probably got a bad cap throughout the whole thing, but
Right.
I'm sure it's a bad cap in the audio. So I got to fix that before I go to the RF, and
What
I have
vintage?
changes.
When was that built, do you know?
1965.
65.
Oh, yeah, that's about the time the one I had was. Yeah, it was about that. And the one that I had was made by a couple of different, well, it was made by one manufacturer, but several different brand names got plastered on the thing.
I just thought it was kind of cool looking. I liked the face of it, and it's kind of neat that it makes a nice little portable radio.
Oh,
Mhm.
yeah.
Yeah.
You know, GM made those for like Oldsmobiles and stuff like that in
Oh,
like
yes, they
57,
did.
58. And what was interesting about them was they used the car's audio output section when you plugged it in,
Ah,
so that you could drive the speakers. Because when you're dragging it around, it just had little tiny transistors.
yeah, this one does the same thing. There's a slot in the back here, and then when you plug it in, I have the ability to set it for 6 volts or 12 volts because this is a little power adapter. I can plug an antenna in as well as external speakers. And I think there's a output to go to what was it called? It's that one where it takes the FM and converts it into stereo.
Oh,
Um,
multiplex.
yeah, they
Yeah,
call
it's stereo multiplexer for FM.
Yeah, and it's got all of those, and I thought, wow, that's pretty advanced.
It probably uses the car's antenna too.
It does, yeah. You can put it in,
Ye-
and or you can
Mhm.
pull this one out. It was just, it seemed like a cool radio, and I couldn't pass it up when I got down
Yeah,
to $5.
that's not so bad. Can't complain about that.
No,
That's only the actual second thing like that I've ever seen in person, really.
maybe I'll bring it into a club meeting or something sometime once
Oh,
I get
sure.
going. Well, shall we get started? Jake, did you have anything
Yeah.
beforehand?
Well, the only thing I was gonna mention is this weekend, this coming Saturday, we have our trash bash. So you can bring your unwanted electronic gear, radio related stuff, and um, come on down and take a look at what other people have brought, and hopefully you can find some interesting and cool items, possibly a radio project. We'll also have pizza available for $2 a slice, and some sodas too. Let's see what else. Oh, and I think there's going to be an auction as well.
That was good. And I'll bring the remaining AM generators for the people that haven't picked those
Oh,
up. So,
Okay.
okay, sounds great.
all right, well, let's get started. Let me do a share here. Hopefully this will be new information to at least a few people. Give me a second to get my screen organized here. So, have you ever wondered why the values are so weird? You know, for like capacitors and resistors, how come they have like 2.2 or 22 ohms or 330? Why don't they just have 300, 350, 400? You know, why not?
Mhm.
Why have all these weird ass numbers? What's going on?
I think I have some 300 ohm resistors.
And you might. It's very possible.
They're old. They're old.
So, you know, some of it depends on how old your stuff is. If you look at some really, really old stuff, you may find values that you can't find anywhere else. And a real common one is a zero 0.5 microfarad capacitor. You know, that's one that you'll see in a lot of old stuff that you actually is really hard to find today. You know, and the question is, where did these numbers come from? So, a little bit of history. In the early days of electronics, there really wasn't any standard. And so, you know, components, they just they were what they were. Um, and each manufacturer might have different values based on what they needed, that sort of thing. And then the RMA stepped in, I think it was in the mid 30s. And they kind of defined a set of standards. And then in 1952, the IEC adopted what they called preferred values based on geometric progression. And that's the real key. And we'll talk more about what that actually means. So, you know, part of the question is, well, why do you want a standard in the to begin with? And really, so much of it has to do with cost saving. It can be really, really expensive to make components to what you might consider an exact value, you know, and so they make them based on tolerances. It's kind of like if you're going to go have a 1/4 inch sheet of aluminum and you want to go drill a hole, if you go grab your hand drill and a 1/4 inch bit and you just hand drill it through there, well, it's probably not going to be a 1/4 inch. You know, you're going to move it around, things like that. But if you want to move up a little bit, you're going to probably need a drill press, and then you can drill it. Or maybe you start going through and you do what's called pecking, and to make sure the hole's a little bit better. And then you're going to use some lubricants and um, uh, heat removal, such as like kerosene or WD-40, something like that on the aluminum to pull that heat away so you don't get the expansion. But if you want to go even more, what you're going to do is you're probably going to drill it undersized. Then you're going to do a reamer, and then it gets into all the measurement and stuff. So, the more accurate you make something, the more complicated the process gets, and the more accuracy you have to have in your measuring tools to make sure, that sort of thing. So, if they can make things at a lower tolerance, say 20% plus or minus, those kind of things, it can really save a lot of cost and lower the end result, to whatever you're trying to make. And most of the times, radios and most things, they can accept a range of components. It doesn't have to be an exact value. There are tolerances. And by doing all this, you actually allow for inventory simplification, because you don't have to have so many different things in your inventory. Maybe you could have smaller amounts. And so it allows the manufacturers as well as downstream to carry less parts to do the same type, to perform their function. So if you think about a linear progression, let's use what we're going to call a decade between 10 and 100. If you look at linear progression, like what we might think, like why don't they create resistors at 10, 20, 30, 40 on up to 100 in groups of, in steps of 10? Well, if you do something like that and say we're dealing with a 10% tolerance, well, your 10% tolerance for a 10 ohm resistor, it could be plus or minus one ohm. So you're going to be sitting in here. But your next one, you're going to have a big gap between what the tolerance of this one is and what the tolerance of a 20 ohm, because you're going to only go down to 18. But on the other hand, if you look at the upper scale of this decade, you're going to notice that between a 90 and 100, there's a huge amount of overlap on what the tolerances could be. And so this gets to be really complicated. Well, if you're going to do this, well, maybe you're going to have a 15 also, because you're going to have to cover something in here. Or maybe you're going to need a 12, a 15, and an 18. And up here, well, maybe you don't need the 90. Maybe you can change these around. So it gets really complicated when you start looking at tolerances, because this isn't ideal where you've got lots of overlap here, very little overlap there. So what they came up with was using, sorry for math here, but they're using a thing called geometric progression on a logarithmic scale. And so if you're looking at the decade between 10 and 100, what they're actually doing is they're building the values such that the tolerances, so as an example, this is a 10% tolerance, will be very little or no overlap. And so they kind of like merge right together. So you got 10 will go from this point to this point. And then at that point, the 12 kicks into here. And then at the top of this range, the 15 kicks in. The top of the range, 18 kicks in. So these are actually built such that when you apply the appropriate tolerance to it, you basically have individual steps without a lot of any overlap or gaps between them. And that's really what this is all about, is just building a nice set of values to where you don't have those overlaps. And all of these start with basically a decade. So then they start over. So go, 10 to 100, and then you'll go 100 to 1,000. They'll follow those same ones through. Now, this is the definition of it here, and I was going to try to rewrite it, and I thought, oh, I'll just copy it straight from Wiki because they explained it pretty well. So basically, they look at a logarithmic scale, and then what they do is they create an E series, and the E series is based on the steps. So 3, 6, 12, 24, 48, 96, and 192 values. And each E series relates to a tolerance. So your highest tolerance, I think, is the 0.05, which is going to have 192 values stepped up. To where if you've got a 40% tolerance, you're going to be only having like 3 values. 20%, you might have 6 values, something like that. I think those line up. I'm not sure. I believe they do. So it's really common also to have different significant digits. Obviously, if you're dealing with, the 1% tolerance, 2%, they might actually go to 3 significant digits to where 3, 6, 12, and 24 are only going to be 2 significant digits just because there isn't as much precision as needed. So this is the most common tolerance that we see. And again, they're called E series. So the E6 means that there's going to be 6 values, 1, 2, 3, 4, 5, 6 between each decade. And that's going to be a 20% tolerance. And so that's why you're going to look and you're going to see values of, so this will be 1, 1.5, all the way up to 6.8. And then it will, it'll start at 10. So this will be 10, 15, 22, 33, 47, 68. And then, it'll be 1,000, and then on and on and on. So if you're looking at 20% tolerant resistors, you're going to see these values here. If you're going to do a 10% tolerance, they're going to add some more values because that's an E12, which means there's 12 items in the series. And the 10% tolerance, you're going to start getting these numbers, which many of them are the same. Some of these are rounded just slightly so that they match. If you try to use the formula, it may not turn out exactly right, but they snap them to match. So like the 3.3 here is going to match the 3.3 here. The 4.7 is going to match the 4.7. The 6.8 is going to match the 6.8. But they're going to add in the 5.6 and the 8.2, those. Now, if you get down to a 5% tolerance, that's when you start seeing like the 9.1s, the 7.2s, things like that. So
Now, on the band on the 20% on a resistor, what color would that be? Because I know like 5% is gold and 10% would be silver.
Yes, and I don't know. I think if they're not banded, it's 20. If I'm not mistaken. Maybe
Yeah,
Byron, you can help
I think
me.
that's true. Yeah. No color at all.
Yeah. Which could be a 10% that the color worn off. Who knows? It's probably 20% anyway when they're that old. But as I remember, I think that the 20% has no band. And then let's see.
Yeah, 10 is silver, 5 is gold.
So if you see, something like a 9.1, which I recently was working on one that I needed a 9.1, that that's going to be a 5% tolerant or a 1% or something smaller. It's not going to be a 10% because, the E12 series that's 10% doesn't have a 9.1. So, that if you can't read that last band, you just know it's going to be either a 1% or a 5%. It's going to be a higher tolerance one. And then if you notice at the E96, that's when we start getting into more decimal places here. And so you're going to see these. I don't see these too often, but every once in a while you do. Now, there can also be, especially inside multimeters, there can be very, very unique values. And they're doing it, the VTVMs and stuff like that. those are a lot of times they're going to have wire wound precision resistors to very specific values. Those you're probably not going to find in the standard resistors. These are the standard resistors that most everything is going to be built with.
The thing is, the 1% resistors have 3 bands before the multiplier.
Yes,
So there's an extra band in there.
that's a great point. See if this picture.
Yeah, it confused me the first time I saw that.
Yeah, yeah. So you're going to see instead of 4 bands where there's a the tolerance and then 3 others, you'll see more bands. And there's some that even have more bands than that. Some of the new stuff is really, I mean, I look at it and I just grab my own meter because I can't figure out what it is. There's so many different colors and they're so small that you can't tell what the color is half the time anyway. But that's the whole I mean, so this is a relatively short presentation, but I found it interesting, and so I thought I would pass that on to everyone. How many people knew about this? Did anybody know about this?
I knew about it.
No, well, so
I didn't.
Um,
So that's
The next
new
one
for
is
me.
capacitors, because I deal with the old ones, so I've got a +80 to -20 tolerance. And I
yeah,
work with
and
those quite a bit.
yeah, and most electrolytics are +80 -20, and so that just means it's a real low tolerance. And the thing is, these numbers are used for capacitors also. If you notice that, like the 6.8, you're going to find the 0.068 microfarads, or you're going to find a 390 picofarad capacitor, something like that. But they're almost everything now in resistors and capacitors are going to be using these numbering schemes because that's what those are the standard geometric progression numbers that they're going to use.
Yeah, what makes the color codes more complicated on capacitors is the temperature coefficients,
Oh, yes, yes.
which is a mess.
And I think some of the old capacitors, didn't they also have some of them had a voltage too, right? There was a color code for the voltages.
Yeah.
Yeah,
Yep.
let's try to make it as
And those
hard.
kind of followed the same color as the resistors.
For the values, but yeah, the tolerance, I'm sorry, the temperature stuff was odd.
Yeah, it's like if you got a blue band, you got a 600-volt capacitor generally.
Yeah,
Right.
the voltages were weird too. The other thing I would mention now is that tech scopes, you may have noticed, have the similar 1, 2, 5, 10 sequence on the voltage and the time bases.
Ah,
So it's a similar logarithmic idea.
I didn't notice that.
Yeah, for both the time base and the voltage, range.
I'll have to go back out to the garage after this.
Mhm.
yeah. So I mean, and again, it all relates to this geometric progression based on a decade to where you basically don't have these overlaps, and so you can minimize the amount of values and maximize the range level for a particular tolerance. So it's really all based around tolerance. And I think back in the late 1800s, there was a guy named Renard, if I'm not mistaken, that initially proposed something similar to this. And so there was something called the R series, and that relates to his version of this. I didn't stick that in there because it's more fluff than anything, but I just thought I'd point this out in case you ever wondered why the heck all those weird numbers. It's all
I'll
about
have to-
standards.
I'll have to stop making fun of them. There was a lot of good reason.
Yeah, exactly.
And sometimes that's referred to, like if you go to just capacitors or I'm sorry, just radios or something like that, they refer to pre-war and post-war evaluations.
Oh, yeah.
Mhm. Yeah.
Yeah, and that actually relates to where is it here? This 1952, the RMA tried to define something. And I think it was in the late 30s, but in 1952, that's really when they locked it in. But people were doing it prior to 52. They just adopted that as a standard that they called the preferred values.
Yeah,
And
I guess, I don't know for sure, but I think that it was the war production that, kind of said, we need to standardize on this stuff.
it forced it, yes.
Yeah.
And they were, because we were working with the Europe, everybody in Britain and things like that. There was a huge effort to try to standardize so that we can, we would be able to swap parts back and forth, things like that.
Yeah, not to mention bolt threads in Britain.
Exactly.
Well, they
Although-
standardized the printed ohm readings on speakers also.
Oh, is that right?
2, 4, rarely ever ever see anything 6. It's just 8 and 16.
Mm-hmm.
2, 4, 8, and 16. But they used to be marked differently. I have speakers that are marked 15 ohms.
Oh,
So that's everything I have for that. Like I say, I thought that might be interesting for people to
Well, that
if you
is.
didn't know about it.
Yeah, thanks.
Yeah, that was great.
very informative, no less.
And like I say, now maybe you shouldn't make as much fun about the numbers as you normally would.
Right.
What the heck? There is a reason. Holy cow.
There is a reason for all these colorings.
I'm curious enough though that I'm usually always putting a multimeter on them. And I use a lot of carbon comp so they can drift, and I've got, I guess I'd call it undervalued on some of the carbon film.
Yeah, but if they're within tolerance, that's the key. Because when they make them, it's all about, and of course, then your other question is how accurate is your meter? But especially when you got meter leads and everything else going on. But again, it's kind of like drilling that hole, right? It's you're going to pay more for something with higher tolerance to get closer and closer to that exact number.
Yeah, I've got, I don't know, they're under 1% accuracy on a couple of resistors I picked up. Yeah,
Wire
some
wound seem to
swap meter or something.
hold the value a little bit better. The carbon ones are going to be a little
these
more variable.
Except
Yeah,
for those
these are-
Candom things.
Oh yeah,
yeah, those are fun.
Well, I mean, I think
Very-
they make the contacts by crimping the surface, and so there's no solder contact. It's just a crimp.
right. Yeah, the wire's good, but they're either off or they're open, right?
Pretty much,
Mhm.
yeah.
Or a pile of ash.
Yeah, that's true.
I think that's what the metal is there for, is to contain all of the smoke.
Yeah, you should be able to check your multimeter with 1%ers anyway. If you bought 5 1%ers or 10 1%ers, you should be able to check your multimeter.
Yeah, the thing to keep in mind, and I learned this as I was doing machining, and actually when I was working with this one design engineer on a big microcontroller. So often when you're doing designs and stuff, don't get so fixated on a specific number. When I was doing machining, I was trying to measure everything as tight as I possibly could. And so many things don't really need that level of precision. And you're going to be wasting time and energy for something that just doesn't matter. When I was working on this microcontroller with this engineer, he stopped the whole project and he said, for now on, we're only going to have 5 values of transistors that we're using. Because we were designing them individually through a CAD program. And he said, all the engineers are going to only use 5 values because it's just too crazy that everybody is trying to figure out the exact little thing. And believe it or not, because we limited it to 5, we could build what we called standard cells, or we built these standard little modules that we could pop in. And we were able to get the design done so much faster after he did that, rather than everyone thinking, oh, it's got to be down to the, the 4th decimal point. Nope, you pick one of the 5 or you're not working here.
Yeah.
Any other thing on tolerance? That's something we all need, right? Lots of tolerance.
Yes, tolerance.
No, I was just commenting on checking the multimeter accuracy.
Oh,
When you had
Oh,
1%
yeah,
resistors, you could see if you had 10 of them, you could kind of see if you have your multimeter coming close.
Well, I was going to report that I was able to successfully rewind that field coil that I haven't done for 6 months.
oh,
Oh,
awesome.
nice.
I put it on a drill press and found a screwdriver that just fit into the middle of the coil. And then on the other end, I just put a piece of conduit through the supply. What do you call it? That it came on the spool, and put that in a cardboard box. And it took about 15 minutes. But and also I put the drill press on an auto transformer so I could spool it up slow.
Oh, nice idea.
Yeah.
What was that, the one where I 3D printed the form, or?
Yeah, yeah,
Oh, it
worked out
was.
great. Worked out great.
Oh,
So then
excellent.
the only trick was, I mean, when you solder to those things, I guess what you have to do is take a blob of solder onto the number 35 wire to burn off the enamel or whatever they're using these days. And then you can solder to a bigger wire. And so I did that. And then the other thing was I basically hot glued it to the side of the coil. So, I would have some structure to those big wires that wouldn't break the little wires. And it was supposed to be, I think it was supposed to be 1,500 ohms, and it turned out to be 1,400 ohms. I was like, well, that's fine. So, yeah, it works great. But, the key to that was having a speaker that I could take apart. Usually those field coils the Philco ones, example, are welded shut, so you can't possibly
Oh, right.
take them apart. But this was a American Bosch, and so it had the speaker. You could actually pull it apart with screws. It was screwed together. The pole piece, you could pull the back part off.
Did you do anything special to keep the tension right so that, it's not too much that you break the wire and
Well,
not so loose it slaps around?
the spool that was feeding it, like I say, I put that on a piece of 1/2-inch conduit, and so it was a pretty close fit. It wasn't, real tight, and it wasn't real loose, so it didn't jump around when it was feeding. But the other thing that happens, which, if you think about it a little bit, you realize the take-up spool, the supply spool, is going to get faster and faster because the take-up is getting larger and larger diameter, and the feed is getting a smaller and smaller diameter. So when we got really close to the end, the feed spool was really spinning, but we just used a finger to guide it on there for 15 minutes, and it worked out great.
Excellent. So does anyone want to report back on the AM generator builds? Is anybody making progress on them?
I haven't really started yet. Last week was really busy.
Mine turned out great.
Excellent. And in fact, Martin had some comments. Let me do a share here for others, make sure that you don't make the same mistake. So in the schematic here, if you're looking at the schematic, see if I can zoom in. I don't know if I can zoom in anymore. Oh, here. You'll see this is the frequency selector switch. This is that rotary switch. And you're going to see the numbers 1, 2, 3, 4, 5, and 6. These numbers don't mean anything on any of the switches or potentiometers. Ignore those numbers. These are these were part of the symbol, and I screwed up and I didn't go in and edit the symbol. I should have. If you look on the rotary switch itself, and I think I mentioned this in the document, the common pin is the one that's in the middle. There's two of them in the middle. It's the common one. And Martin, I think you said that it's actually labeled a V. Don't connect.
If you use pins 1 through 5, then the one labeled V is the common one.
Right.
And
And
you said if you use the other half, the one labeled something else is the common one.
right. So that again, ignore the numbers here. Do as I mentioned in the instructions. Go through and just ohm it out and make sure you know where they're going. But the two pins in the center are your common, and actually that's two rotary switches. There's one that looks like this with 6 pins, and then there's another one that looks like that with 6 pins. I'm not using that other half. I'm only using half of it. And in fact, we're only using 5 pins of the 6. And that's the one where if you want to, you could actually have it connected to do the 6 pin, go to another 10K resistor if you want, and so you'd have an additional frequency. But again, don't look at these numbers as meaning the numbers on the rotary switch. I apologize for that. Thank you, Martin. I appreciate it.
Sure. And it was a pleasure to build.
Excellent. How were the instructions in general? Easy to follow?
Good. Yeah, that was the only place I ran into trouble was I was following the schematic and
Yeah, that'll teach you.
Did you read the instructions?
I did actually, yes.
That'll get you every time.
How did the soldering go? Did you find that pretty easy to mainly connect the wires together? Any hints you could give to other people on something that you did that made it easier?
Particularly on that rotary switch, don't use too hot a temperature. And you mentioned that in the instructions because the plastic on that rotary switch is so it'll melt at a glance.
Yeah, and I've seen that on a lot of the switches, even any of those micro switches, any of that. What I do is I'll usually take my iron, I'll just touch it with solder and then tin it really fast. And then I'll take the wire and I'll tin the wire. And then when I go back, I'll let it cool. When I go back, I'll just do a quick touch to get them to connect.
And that's the process I used, yeah.
Yeah, I don't know. They just don't make them like they used to.
You don't. And in some cases, that's a good thing.
Yeah, yeah, that's true. Well, hey, Mark, how's it going in Hawaii? I think you're on mute.
He survived the tsunami.
Yeah.
Yeah, the nothing. It was nothing, and that I figured that would be the case because the Japanese quake in 2011, which was a stronger quake, only it made the tidal wave it produced just came over. There's a short seawall in town, like 6 feet or something like that, and it came over that and damaged some businesses on the first floor, just some, and there was one house that got lifted off its foundation. Well, that quake was lower intensity, and then they had the reporting coming in from like when it went over midway and stuff, it was like a foot or something like that. So I thought, yeah, it's not going to do anything.
Right.
So, but they got away off the beach. I mean, there was some flooding, like in Hilo, it's just on the other side of the island. They had a 5-foot rise of the sea level,
Oh,
which
wow.
is enough to cause some flooding in like a few hotel and a few businesses. Just low level flooding, like in the parking lot or around the building. So, but if you had somebody that was out in the water, I mean, on the shore, didn't know better, So, so they ran the sirens every hour to get everybody to tune in and, get away. But because they don't know until it starts getting closer to what it might do, So it was about half the tidal, I think, height that they were predicting. They think they predicted up to 10 feet, and in some places, and it did 5. So
Yeah, they had the alert going on the Oregon coast.
yes, right, exactly. In California, so because it really is not that much difference in distance. Just an hour or two difference, I think, something like that.
Yeah, the good news here was it also hit at a low tide, even though it was only going to be like a
Now
1
here it hit at
footer.
high tide,
Yeah, and that
Yeah.
makes a big difference.
but like I say, I just from the experience and I wasn't here during that quake, but I know I know the lay of the land and what it did. We're like at 120-foot elevation. Now, actually, they have the evacuation signs above our higher elevation above our place, which I think is a mistake because there's no geographic focusing. I think there are other places where they have it a safe zone and it's flatter, and I think they're more at risk than we are. So who knows?
Yeah, the main thing is like here was you just didn't want to be out on the water because
No, that's the thing.
the
You-
high
you-
current.
You gotta. I'm gonna turn my volume up here a little bit, because, like I say, you don't know who's out on the beach, so you gotta do all those things for the people that don't know, tourists and stuff, or somebody that doesn't know. My neighbors, of course, this is the first time they experienced that. They're 10 feet lower elevation, and they said, "Are you going to evacuate?" I says, "No, I'm not worried about it." Yeah, but they did drive up above. Uh, it's not that far. The evacuation spot is not much higher elevation than our place is. Maybe another 20, 30 feet, something like that, higher or whatever. But they went up there, and once they got up there, the police department wouldn't let you drive back down. So they ended up at about 10 o'clock deciding that nothing much was going to happen. So they had to walk home
Oh no.
and get their car in the morning because they weren't going to let people drive back down until they got the official "it's all clear" type of thing. So, but they did a good job of. I mean, they have to do that, But it was fortunately no real damage or anything. So
Well, we have friends who live in Honolulu, and they said all the ships had to leave the docks and go out into
because
the water.
that's correct. Now, during the Japanese quake, a lot of boats, inside the harbors got uncoupled from their mooring and stuff because maybe the mooring lifted off their whatever because of the sea level rise, and they were sloshing around for several days afterwards, moving, drifting back and forth in the harbor, and because the water didn't have a place to go, so it kind of got in there and kind of just reverberated back and forth. There was unusual currents and things for several days afterwards, because that the wave propagation across the ocean, and then it bounces back from the other side at a lower intensity and comes back. And so it was, it disturbed things, but nothing really, too worrisome. So, but now, I guess the Rush, I guess that where it hit there, I guess that's where I think the Russians have their submarine base at. So I heard they had some damage there. And then one of the guys was one of my ham radio friends. He was in some way involved with intelligence. Maybe I don't know if he was in the government directly or as a contractor, but he related a story about the undersea cables and stuff and how they tapped into their phone system back in, I think it was in the 60s, or which is kind of funny because apparently they had American telephone equipment back then that they got from us, and they wanted to, of course, listen in to the military base and the government, what they're doing, because that's about the only people that have phones. And so they're trying to figure out how to tap and find the undersea cable so they could tap into it. And he said, somebody goes like, well, you know, when you have a river crossing, they put up those signs that says, you know, warning, cable crossing. So he said they sent a submarine over and looked, and sure enough, there were the warning signs. They found the cables and tapped into them for years. To get intelligence. I guess they had some sort of module that would couple to the cable. It wouldn't cut it. They would couple to it and record for a month or something, or a couple months. They didn't have to go retrieve it and change it every few months. But anyway, it was kind of funny about a little story about how they found the cable crossing and found where the cable was at. So.
Oh, those must have been the days of copper wires still.
Yeah, well, sure. Yeah, that was before. That would be the undersea cables before they had fiber. Yes, that was back in the 60s or 70s.
You know, I think if they did that, there must be so much corrosion there that those spots where they cut into it had to have gone bad in a couple.
Well, they
months
didn't cut into
after
it. No, this was something that they put on the cable.
Oh, just
and
inductively.
probably by inductive coupling or something like
Yeah.
that, picked up the traffic.
There you go. Yeah, of
and
course.
and
sure.
they had a recorder, and so they would just go, connect, put it on the cable, and then every few months, however long the thing would, fill up the tape or whatever how they're doing it, then they would go in there and change it. So
Yeah, no, that makes sense. Yeah.
yeah.
I may have mentioned this before, but the termination of some of the Pacific cables is nearby here on Evergreen. And there's a building across the street that the NSA has there, and they basically use splitters to duplicate everything that comes in on that cable.
Oh yeah, imagine so.
It's an unidentified building with a big fence around it.
Mhm.
Nothing subtle about it.
Yeah.
Yeah, but you don't know about all the underground fortresses they built on the long side Portland.
Yeah. But anyway, that's actually nothing really, not too much, no damage here anyway. So good. It was a good, as they say, though, a good civil defense exercise, getting the word out. People know, and good for when they need it someday. It'll work. So
At least they didn't send out the message of imminent nuclear attack this time.
no,
Yeah.
that was a whole different thing.
What are you going to do? Head to higher ground?
Well, I was driving up north to Waimea, actually for a ham radio swap meet. It was Saturday morning, and we were driving along, and the phones went off with that, dee, and on it said, this is not a drill type of thing. This is the real thing, and it's like, what, and you're wondering, and I called back home. I said, "Are the sirens going?" No, they were because the sirens weren't going down here, and it didn't come on the a lot of the media, so it's kind of like this doesn't seem right, and but for a while you still were wondering, is this the real thing, and what are you going to do, and it took them about a half an hour to sort it and send the all clear message out, but there were in Honolulu, there are people that some inventive people went and opened up the sewers and took their families and stuff down inside the sewers as a place to protect them underground. I mean, I thought that's pretty clever, actually, but
you gotta surface sometime.
Yeah.
So you might not hit it right off with the nuclear fallout, but I don't know.
So
I guess
that's,
we can find something to eat down there.
Yeah, well, I know, but they were just going for someplace to, what are you gonna do right now? So yeah,
You're talking about the anniversary of Nagasaki, Hiroshima, then.
Yeah,
I think
that's right now.
today, right?
Yeah, I
Yeah,
think that's today.
yeah,
Or
I
yes,
heard
yeah,
it.
the 6th, was it the 6th?
Yeah, I heard it on the radio.
Yeah. My dad was a B-24 pilot. He was actually in the air over a different part of Japan, several hundred miles away on a different mission. The regular, they were they did precision bombing, like take a bridge out or a factory or whatever type of thing. And he had told, you know, told a story, says he saw this, they saw the cloud off in the distance. And you kind of think, yeah, dad's, the dad told us, years later told us, stories about things that happened. And, but still you wonder, is there a little bit exaggeration to that? But, one of my nieces, found, out which plane, the numbers of the planes that he flew. And we found, in the mission, we had a limited amount of stuff on his missions and stuff. Most of the stuff's lost and the records were lost, but we did find that it was on one of the planes he was assigned to, and on that day, he actually was in the air on mission. It's in the records and stuff like that. So it's like, oh, okay, he wasn't stretching the truth too much about what went on. Anyway, I got off on a digression.
But you still needed radios. That's what you come back to, Mark. You
Yeah.
still needed a radio.
Oh yeah, yeah,
That's how you segue back.
that's right. Yeah, and they did have radios on the plane.
You had to have radios. Everything was
Definitely.
radio.
Oh yeah.
Radio, radar, radio.
Well, they didn't have radios in those planes, but just they had the
Tubes. They had vacuum tubes.
yep. What's the, I forget the
Capacitors,
numbers.
resistors.
The arc fives, I guess they called them, those transmitters, and then also had, I don't know if you've ever seen these little they're kind of like almost like a plug-in unit with a couple of dials, but I think they're like the bandpass filters or the transmitters and stuff, because they had those for different frequency ranges.
There's just, again, a tremendous amount of technology and advancements during those
Yeah.
days.
Yep.
For what they had and how they were progressing. And
yeah,
Watson, can you hear me, or whatever that was?
Yeah. So how things back in Portland and vicinity?
Today actually was a cloudy day all day, kind of
Yeah.
misty, a little rainy here and there. So it's cooled off, but it's supposed to break. So I don't know what it's caused from exactly. I'm assuming we got the extra clouds from the lot of forest fires.
Oh.
So I don't know if that's caused the upper atmosphere to change. I haven't looked into it much, but there's quite a few fires going around the area. You look at the map and there's a lot of fires around. So I don't know if that's why we clouded up all day. So it's still warm. It's got really humid because it's been misty, rainy, and it's like, man, it's humid.
Yeah. Well, we've been pretty. This is typical. This time of year, this time of the summer, we are more humid and hot and about.
Yeah, we're still in the 70s, during rain, and it's just like, it's definitely a little sticky.
Well, the difference here is that in the summertime it doesn't cool off as much at night usually. So where the wintertime, it gets comfortable and you can open the doors and windows and stuff at night and cool the house down. So
yeah, I was over there. I lived over there during I'd call it the winter time, but it was cold when it rained. It got cold. So
really.
In January, February, it was actually it got cold. It was like it wasn't freezing, but it was cold compared to what you're climatized for. Today, like I said, it's just in the 70s, and kind of misty rain, off and on here or there, depends on where you were, but it's really sticky humid when I've been in the car. Most of the day I've been driving somebody around, so
Mm.
it's sticky.
You guys getting ready now? You getting ready to go up to Shoreline?
Shoreline's the next one, yeah. Well, we got our trash and bash this Saturday, I think.
Oh, okay.
Yeah, it's this Saturday.
So we'll work that out, and then they're charging for pizza, so and drinks. If you want pizza and drinks, you got to pay now,
Oh, okay.
which has never happened before when I've been here.
Oh, okay.
I don't know. We have new leadership.
Yeah.
They decide, and you just decide. So there's a new government operating in our club now.
Well, I guess I don't have anything else, but thanks everyone.
Yeah, I'll have
thank
to go
you.
back
That
and-
was a good presentation.
Yeah.
I'll have to go back and look because I got in kind of late into there and on the explanation of why they did the progressive different values, but
It's basically they did a geometric progression so that there's no overlap. Here, I'll share real quick, just for you, Mark. I wouldn't do this for anyone else. I can go back and find my presentation really fast here. That was the thing. This was a really short presentation, so
yeah, I just saw the graph at the end there where you had the
the bottom line is if they did a linear progression, for a decade, they just went like 10, 20 on up to 100.
yeah.
The problem is, if you had something like 10%, there would be lots of gaps in between here and there'd be huge overlaps here. So
Ah,
what they did instead was they used a geometric progression on a logarithmic scale. So for a decade from 10 to 100, there's no overlap. Where the upper end of the 10 is where the lower end of the 12 starts.
ah,
And then these numbers were chosen so that they just kind of progress naturally all through that 10%,
okay.
which is,
Very,
yeah, really cool. And then what they did,
yeah, it is, isn't it? Yeah, that's just about where I got the tail end of that, but that makes sense. And so,
yeah, so that for the E6 series, they called these the preferred values, and they're the E series values. So if you're doing a 20% tolerance, you only need these specific resistors, and then you will fall all the way from 1 to 10, and then or a multiplication of or division, however you want to do it, any factors. The E12 series means that there's 12 in that series, and that will cover the 10% tolerance. And so you're going to see some extra numbers that you didn't see here, like the
gotcha.
5.6
Okay.
and the 8.2. Yeah, and then there's a 24, which is a real common series for the 5%. Then the 1%'s an E96, and then the 0.5%'s a 192.
Hmm. Okay.
Yep. So that's why they did it, was just so that by picking this limited number, they can actually cover the whole decade.
Sure.
To where, although this makes sense in some respects, would cause you a lot more grief in the manufacturer side of things.
Yeah.
So there
Very
you
cool.
Yeah, I was wondering one day myself, I was going, why are these numbers the way they are? So I did some research on it and I go, oh,
Yeah.
okay, that's really cool. Then I got thinking
Yeah.
about this time and I thought, I wonder if anybody knows this.
I mean, I figured there's a reason behind it, but I didn't question the same thing. I never really questioned, how they come up with those, but
Now we know why.
yeah.
Now, how many people here on Zoom take a multimeter though and actually check at
Oh,
least a few of the parts?
I quite often will check. Now
Yeah.
um I've restored several national shortwave, national receivers. And they were in like I think the 50s era. And apparently, the vendor they used for their carbon, I guess their carbon comp resistors, um, apparently were very susceptible to moisture. I guess moisture changing their values, because I got
Heat will cook them.
what's that?
The
Well, heat will
heat
cook them, but
actually will, and
Yeah.
usually it raises most of the older stuff, even just sitting without anything, you might
Yeah.
call that moisture, but it'll always raise the
Yeah, that's what I found because I
resistor.
got this. I think the first one I did was a National 183, which that has 15 tubes. It has a lot of resistors in there. And, I recapped it, they're laid out very nice, nice kind of grid pattern way a lot of the components are, and they're very nice to work on. And place all the caps, and I'm starting to check the stages, and the gain still didn't, a lot of times that'll bring things pretty much to life. And it was a little doggy on some of the IF stages and stuff. So I started checking resistors, and like and there were certain values which were much worse than others. Like for example, maybe the 10Ks were pretty much near tolerance, we're not too crazy, but like maybe it was like a 68K or 100K value, something like that. They were 650K, and I found it consistent. I was going, I all the whatever they were, all the 100Ks were at 600 or 700, they're just crazy numbers. And I think some of the other values, the same things, like the 47Ks were some, 10 times or some crazy number of times their values. And then, like say, you'd find some values that didn't seem to, they were still out of tolerance typically. So I ended up replacing almost every single resistor in the radio, which is a lot of resistors to change. But so then I had a 183. It came from the same place I bought, and they sat in the cement floor probably for who knows how long. Same thing. And then I acquired other nationals in that same vintage, like a NC 125. Anyway, one's built in that same era, from a different, bought it from somebody else, different sale or whatever it was. Same thing. I just all seems like almost all of them in that era, the resistors are just way out of whack. So and I maybe the brand that they vendor resistors they were using were just more susceptible. So
Yeah, I've seen the same thing. If you get a certain one that whatever they used, all of a sudden every resistor in there is going to be off by huge amounts, factors
yes,
of
and
10.
yep, that's what I ran into. And I just figured they were, like in the case of the one where the two receivers were stored in the guy's garage on the floor. And, uh, uh, cement slab, but it's not going to be the driest place, over the years. And so I just I guess this probably wasn't the driest location to store the radios. So they were not in bad shape. They weren't very corroded or anything, minor issues that way, but just they apparently absorb, I assume it's absorbed moisture over the time. Now I've had some of the military versions, a very similar receiver, and found that they were right on. So, a little better quality resistor, I guess, and they didn't drift near as much. But
Well, I'm going to drop off. Thanks, everyone.
yeah, I'm gonna get going too. So just good to
Yeah,
say.
thanks, Mike, for the presentation.
Yeah,
You bet.
yes, very good. Just good to jump in and say hi and see how everybody's
Oh,
doing.
yeah, as
So
always,
yeah, All right.
Well, oh, Mike left too quick.
You guys take care.
Yep, you too.
All right.